that is less than 30, we have to do some additional things. We have to check the probability plot to make sure it's approximately normal. We have to check the box plot to make sure there's no outliers. Go to Graph and scroll down to QQ plot, highlight the variable, and press Compute. So if you look at the graph, it's approximately linear, therefore the population could be assumed to be approximately normal. We need to also confirm there's no outliers, so we're going to go to Graph, Box Plot. I'm going to highlight the variable, and let's draw our box plots horizontally and compute, and we notice that there are no outliers on this graph. So all the conditions are met, and we can do the problem. Now to calculate our confidence interval, we have to go to Stat, T-stats, one sample with data. I'm going to highlight the variable, and we want to do a confidence interval for 99%, so let's change this to 99% and press Compute. And here is our lower limit and our upper limit. Thus, we are 99% confident that the mean weight of pennies minted after 1982 is between 2.4516 and 2.4767 grams. A Gallup poll of 547 adult Americans conducted August 13 through 16, 2017 asked, how much total time in minutes do you spend commuting to and from work in a typical day? The survey results indicated that the sample mean was 45.6 minutes with a sample standard deviation of 31.4 minutes. Construct a 90% confidence interval for the mean commute time. Is it possible that the mean commute time is less than 40 minutes? Is it likely? First, perform the calculations by hand and then compare to the StatCrunch output below. So the degrees of freedom is going to give us 547 minus 1, or 546. The standard deviation is 45.6. To find the column, we do 1 minus 0.90 divided by 2, which is 0.05. Now the degrees of freedom was 546, so the closest degrees of freedom that I can use is actually 100. So our critical value is 1.660. So we're going to use the degrees of freedom to determine that we need to use T, since this is less than 1,000. This gives us 45.6 plus or minus 1.660 times 31.4 divided by the square root of 547. I want to simplify the right side of the plus or minus first. And that reduces to 2.23. We have to do the subtraction between the two numbers first, and then we'll do the addition. And this gives us a confidence interval of 43.37 to 47.83. Now the units for this is minutes, so we will be able to construct our sentence. We are 90% confident that the mean commute time is between 43.37, and 47.83 minutes. It is possible for the commute time to be less than 40 minutes, but it is not likely because 90% of the time we will be correct. So only 10% of the time will we have a commute time that is outside of our range. We're going to go to Stat, T-Stats, one sample with summary. The sample mean is 45.6. The standard deviation 31.4. Sample size is 547. And we want to construct a 90% confidence interval. So let's select confidence interval and change this to 90%. And the lower limit and the upper limit is given here. The 2006 General Social Survey asked 54 adults the following question. If ever married, how old were you when you first married? This sample yielded a sample mean of 22.2 and a standard deviation of 4.9. Construct a 95% confidence interval for the mean age of adults when first married. First, perform the calculations by hand, then compare the StatCrunch output below. Since the degrees of freedom is less than 1,000, we're going to use T instead of Z. We'll calculate 1 minus 0.95 divided by 2, and that gives us 0.025. Since n is 54, the degrees of freedom is 53, and the closest one is 50, so that gives me a critical value of 2.009. Here the sample mean is 22.2, and we're going to add that to the critical value of 2.009 times 4.9 divided by the square root of 54. We're going to simplify the right side of the equation first, and that gives us 1.3. We're going to add and subtract these two values, and our confidence interval now becomes 20.86 to 23.54. Thus, we are 95% confident that the mean age of adults when first married is between 20.86 and 23.54 years of age. StatCrunch, go to Stat, T-Stat, one sample with summary. The sample mean is 2.22. The standard deviation is 4.9, and the sample size is 54. We want to construct a 95% confidence interval and compute. So our lower limit is given here, and our upper limit is here. Here's our StatCrunch output, and now our conclusion is we are 95% confident that the mean age of adults when first married is between 20.86 and 23.54 years of age.